In this video, let us see what do you mean by an exact differential equation. So the format is m dx plus n dy is equal to 0 is called to be exact if it satisfies this condition, that is partial differentiation of m with respect to y and partial differentiation of n with respect to x should be equal. So we'll be wondering, so what does this m? This m is a function of both x and y. This n is also a function of both x and y. That is why partial differentiation is coming. Because if n is a function of x alone, then I will write dn by dx. If n is a function of x as well as y, we have seen in the previous problem is the total derivative, then I will write it as del n by del x. So if this partial derivatives are equal, then your solution is integral m dx plus integral n of y dy. So only y terms, pure y terms we are going to write, that's equal to c. For example, let us solve this problem. Y cube minus 3x square y dx. So now if you see m dx plus n dy. This is the format. So what I have to do? What is m? Y cube minus 3x square y. What does n means? Please be careful. This is plus. So everything this we are going to take it inside. So n is equal to minus of x cube minus 3xy square. So please be careful with these things. So minus x cube. This minus second term will become plus 3x y square. This minus and minus will become plus. So we've got m, we have got n. Now what we have to do? We have to check this condition. We are going to differentiate m with respect to y. So only y terms we are going to differentiate. X terms are just a constant. So y cube differentiation is 3y square. This minus 3x square is just a constant. Y differentiation is 1. Now I'm going to differentiate n partially with respect to x alone. So minus x cube differentiation is minus 3x square plus with respect to x. So which is a constant? This 3 and y square is a constant and x if you differentiate 1. So if you see here, both are same, 3y square minus 3x square. 3y square minus 3x square. So this condition is satisfied. Only if this condition is satisfied, then I can write this as a solution. Okay. So let us write the solution. Integral m dx. So your solution is integral m dx. So what is m? Y cube minus 3x square y dx. We have written this integral m dx plus integral n of y dy. So in n, I'm checking is there any pure term of y. What is the first term? Only x cube. So this is not allowed. Now this is a combination of x and y. Combination of x and y. It is not pure y. So there is no term here. So we'll write 0. For example, in this problem, if there is some other term, I'm just writing for example. For example, if this is some y cube, then I will write this y cube here. Okay. But we don't have a y cube, so don't get confused with that. So what I'm going to write is 0. If you have any n term which has a pure function of y, we can write it. Otherwise, we can leave it. Now, I'm going to integrate with respect to x. So, which is a constant? This y is a constant. So, I will write it as y cube into integral dx minus 3y into integral x square dx is equal to c. So, please be careful when you are integrating with respect to what. So, differentiation of a constant is 0. Integration of 1 dx is x minus 3y into x square integration is x cube by 3. Using the formula, integral of x power n is x power n plus 1 by n plus 1, which is a very basic formula in integration. That is equal to c. This and this will get cancelled. So your solution is xy cube minus x y cube minus y x cube is equal to c is your solution. So this is how we will solve a exact differential equation. Now your question is, what if this del m by del y, here before writing the solution you have to write del m by del y is equal to del n by del x. That is why I am proceeding with the solution. What if this is not equal, then how can I reduce it to exact form and then solve by this method? Let us see the procedure. See here. For example, I am telling you the procedure. If this is not equal, del m by del y is not equal to del n by del x, then we will take their difference. That is, we will subtract one from the other, that is del m by del y minus del n by del x. After subtracting, we are going to check whether this is given close to or given m or given n. The question m and n will be there, right? The term is close to m or n. This is case 1. This is close to m or close to n. If it is close to m, then we will compute 1 by m del m by del y minus del n by del x. That is the difference, we will divide it by m. That is why close to m, if it is there, then that term will get cancelled. If this is close to n, then we will divide it by n. Okay. So again, there are two cases. If it is close to m, then I am writing this. We will get this. And then we are going to name this as some g of y. Okay. And if this, I'll name it as, I'll write here itself, f of x. And this is nothing but g of y. So either case 1 will happen or case 2 will happen. If it is f of x, then e power integral f of x dx is the integrating factor. If this is case 1, e power integral f of x dx. If it is case 2, e power integral minus g of y dy. The negative sign is there if it is a function of y. Now, what we are going to do? We are going to multiply this integration factor to your question. When you multiply this to your question will become exact. So, in this video, let us see one problem, either case 1 or case 2. Now, see this question, m dx plus n dy. What is m? X square plus y square plus x. And what is n? xy. What we are going to find? Del m by del y. Correct? So, x is a constant because we are going to differentiate with respect to y. Anything other than y is a constant. So, if you differentiate x square, 0. Y square if you differentiate, 2y. Again, x if you differentiate, 0. Now, here, del n by del x. If I differentiate with respect to x, x differentiation is 1, y is just a constant. Because if it's in multiplication, differentiation of 5x, what you will do? 5 into 1. Because it's in multiplication. What differentiation of 5 plus x means? 0 plus 1. That 5 won't come. So that is the difference. Why we are writing 0 here? Because the constant is in addition. Here constant is in multiplication. Now this del m by del y is not equal to del n by del x. Now what we have to do as per the procedure, we are going to find the difference. What is the difference? Del m by del y minus del n by del x. What is your first answer? 2y minus y. This is 2y, right? First answer. Second answer y. 2y minus y is y. Now what we have to check, is this close to m or is this close to n? Now see here, this is m, x square plus y square plus x. What is n? xy. Now obviously it is close to n. So what we will compute? 1 by n into del m by del y minus del n by del x. So your step 1 is checking whether this is equal or not equal. Once it become not equal, your step 2 is checking their difference and whether it's close to m or n. And your step 3 is, if it is close to n, I will divide it by n. If it is close to m, I will divide it by m. So 1 by n is xy into their difference, y. This answer we are writing. Correct? So this y and y will get cancelled, 1 by x. This is a pure function of x. Now what we have to do, step 4, we are going to find the integrating factor. Step 4, what is the integrating factor? e power integral f of x dx. Remember, if it is close to, in case if it's close to m, then your integrating factor will be g of y and e power minus g of y dy we will write. Since it's x, we are writing e power integral 1 by x dx. Integration of 1 by x is log x, because differentiation of log x is 1 by x, integration of 1 by x is log x. Again, e and log combination means e power log of something means that answer will come. So you multiply m and n by the integrating factor. This is your integrating factor. This is going to be your step 5. You are going to multiply by the integrating factor. Step 5. Multiply m and n by integrating factor. So your old m is x square plus y square plus x. You're going to multiply this with x. And your old n is xy. And again you are going to multiply this with x. Now, if you want, you can write like this, or new m is x cube plus xy square plus x square. And your new n is x square y. Now we are going to check whether del m by del y is equal to del n by del x. Always you check del m by del y with respect to y. 0. Again x is just a constant. Y square differentiation is 2y. Again x square differentiation is 0. And del n by del x. X square differentiation is 2x y. So if you check, both the answers are 2xy. Now, as mentioned in the previous problem, we are just going to write down the solution because it came, therefore del m by del y is equal to del n by del x. Therefore it is exact. Just refer the formula. Directly I'll substitute in the formula. Integral m dx. What is your new m? This is your new m. Don't write the old m. X cube plus xy plus x dx plus integral n of y dy. What is your n of y? There is in this new n also there is no pure function of y. So in this problem also it's good for us. It is 0 dy is equal to c. So now we are going to integrate with respect to x. X cube integration is x power 4 by 4 plus y is just a constant. This y is just a constant. Take it out. X differentiation is this, sorry, x integration is x square by 2 plus last term again x differentiation is this x or x square? X square. Yeah. Xy square. I wrote it wrong here. 1 second. Yeah, your new m is xy square. I have written y by mistake. Xy square. So y square. So x differentiation is x square by 2. Again new m, one more term is x square. So x square integration is x cube by 3. So x integration is x square by 2. X square integration is x cube by 3. That's equal to c is the solution. So x power 4 by 4 plus x square y square by 2 plus x cube by 3. So what are the things we did? If it is not equal, we are checking the difference. And if it is close to n, we will divide it by n. That is what we did. After dividing it by n, whatever terms that we are getting, that is your f of x. And then e power integral f of x is your integrating factor. And then you are going to multiply m and n by your integrating factor. So this is your old m and we are going to multiply this. For this problem, integrating factors happen to be x. And this is your old n and we are multiplying it by x. Once you multiply, the function becomes exact and hence you can solve it by the normal exact differential equation. Thank you.